Today, I'm going to go over like a few topics. We're going to go over the concept of machine learning, how machines actually learn. We're going to go over the history of AI. How did we get here? We're going to go over the evolution of the intelligence of these machines, how intelligent these machines are, what can they do today. And then my favorite topic, like falling behind, like what happened to the financial services uh, when we were one of the first industries adopting machine learning back in 2010, and all of a sudden now we're like trailing every other industry. So a little bit of root cause analysis over there, and then Nuan is going to take us through some real world use cases that he has seen with his client on AWS. Before diving in, actually, this is something I came across like today. I was looking for the Google keyword trends for AI to see like when the uptick happened. And interestingly enough, like Utah seems to be the amongst the top 3 states in terms of the interest in the word AI. So it looks like we're at the right place. All right. So before going into like more details, I wanted to basically go over the concept of AI, machine learning, generative AI. How are they different? I'm pretty sure you guys have heard this on different stages. So it's good to demystify these 3 concepts. So what is machine learning? Machine learning is basically us enabling machine to learn from data without explicitly programming them to do so. So this is basically your risk model. This is your collection model where you have data on delinquency and you're trying to build a risk model where you're asking the model to learn from the data. What are the top drivers of delinquency or default? Is it like number of inquiry? Is it like past delinquency event? So this is machine learning. This is something that most of us are pretty familiar with. And AI is a much broader concept. Artificial intelligence or artificial intelligence is a much broader topic that is a superset of machine learning, and it's basically mimicking human intelligence to solve a problem. And what is generative AI? Generative AI is actually a subset of machine learning. It's not AI. It's basically us using machine learning models to create new outputs as opposed to basically building prediction or classification. So as you hear a lot about like Gen AI, general artificial intelligence, it's actually good to note that generative AI is a pretty almost like narrow subset of machine learning. All right. So, and what do we need? What do we mean by learning machine learning or like training a machine? This is pretty much inspired by how human we learn as a human. So there are about like 10 different ways human learn. The top 3 ways that human learn are reinforcement learning. This is basically you interacting with your world and getting rewards or punishment. So like a kid touching a hot thing and getting hurt, getting punished, and not doing that next time. The other way that humans learn is supervised. So this is basically we receiving explicit feedback from our environment, from instruction from external sources. So this is like teaching your kid what is blue, what is red, what is yellow. That there is an external source that gives you feedback in terms of like what is what. And then we have unsupervised learning. This is basically an unconscious form or modality of learning where we basically learn by being exposed to repeated pattern or repeated exposure to repeated patterns in your environment where you can like detect patterns and data. So these are, as I said, like humans like learn a lot in a variety of other ways. Like we learn through emotions, we learn through metacognitive like ways where like we learn how to learn. But the top 3 ways that human learn are these 3, and this is exactly how we train machines to also learn. So if you look at brain structure, it's basically a bunch of neurons and synapses. We, as I said, we learn through rewards and penalties, we learn through supervision, and we learn through patterns. And if you look at how machines are actually trained or how machines learn, basically the structure is pretty much inspired by the structure of brain. So instead of neurons, you have nodes. Instead of synapses, you have weights. Learning through rewards and penalties, basically reinforcement learning. This is basically how we formalize like how these machines learn. Learning by supervision is basically supervised learning, and learning from patterns and unsupervised learning. So when we talk about the concept of machine learning, it's basically how we train these circuits of like nodes and weights to operate similar to our brain, and these pretty much three different ways. The latest wave of like AI, like language model, foundational models, they used a hybrid of these approaches. They used a combination of supervised and unsupervised. It's called like self-supervised learning, and then we use reinforcement learning to basically give them more data points. All right, so let's go through the evolution of AI. I'm titling this like from neural network to neural network. So the language models, the ChatGPT of the world that you see, they're based on a neural network architecture. But this neural network architecture is not anything new. This started back in the 50s. So the first version of neural network was something called perceptron. It is a very simple version of a neural network. And then it was followed by rule-based and expert-based systems. So these are the decision trees that you might have seen. And then this period were followed by AI winter, what is called AI winter. There are actually two of those. And this happened because there was a lot of like hypes, there were a lot of like funding poured into AI, and the return was not exciting. So it went through a pretty rough period. All right. And then we got to the 90s and 2000. This is the statistical machine learning era. This is where gradient boosted tree, this is where random forest came about. This is basically like in the 2000s was when the concept of gradient boosted machine learning models like XGBoost that probably most of you are familiar with came about. And so far until like today, we're still like using those in production and financial services. And then in 2006, deep learning came back. So this was basically a notion of neural network in a deeper form. So like a larger form of neural network came about, and there were a lot of like research into it. And then in 2014, we had the first version of generative model. So when we talk about like Gen AI, the genesis of generative AI was around like 2013, 2014. And the concept was something called generative adversarial network. And the concept is very interesting. You're basically pitting two models against each other, asking one of the models to predict or like to generate fake data. And you're training the other model to distinguish between fake and real data. So this is why it's called adversarial, because you have these two models kind of like competing against each other. One of them are trying to generate fake data that might not look like real data, and the other one is trying to distinguish between those two. And based on this, the concept of generative models started blooming. And this is where we have like the first actual models where they were like producing real life like images. And then it was 2017, and this is where the generative language model kind of like started to bloom. And it was basically based on a couple innovation. One of them was a transformer architecture with self-attention. There's a lot of jargon here, but the main breakthrough in 2017 was this mechanism of self-attention, which is, you can think of it as like context, having these model like context aware. So when I say the bank by the river is beautiful, you know, I'm not referring to a financial institution because there is river, there's like other words in the context that these models are able to learn. And this was the kickoff of GPT type model, generative, they're generative, pre-trained, they have been pre-trained on vast amount of data, and they're like based on transformer architecture. And then in 2018, all of these came together. So we had like deep learning, that came in 2016 based on transformer architecture in 2017. And we simply had like better hardware. We had better GPUs. We had better tensor processing units. And all of these combined enable us to get to the language models, to the ChatGPT of the world that you see today. So zooming in on the last couple of years, where have we come in terms of the intelligence of these machines? So back in 2019, this was the first publicly available like GPT-based model, which was GPT-2, where the intelligence of these models were almost like around like a preschooler. And then a year later, we had like GPT-3 that was more like a elementary school intelligence level. And then right now we are like in the GPT-4 era, which is pretty much similar to a smart high schooler. That's the level of intelligence. And there is a kind of like a argument for like, this is going to be an exponential growth. It's not going to be linear. So like in like 5-6 years, you're going to see actually PhD level researcher intelligence in these models, which I don't think that's going to happen. But what the problem is here, it's for most of you who are like looking at like AI models and you're trying to deploy this in your system, the problem is you're not going to hire a smart high schooler to do your compliance work or to do your customer support. So how can we get to a level of intelligence that these models are actually usable? And this is exactly the reason why like LLMs are both overestimated and underestimated. They're underestimated because we look at the current state of these models and we think like, okay, they're making like obvious mistakes, so I'm not going to be able to use this. And they're also overestimated because we think they can replace an entire compliance team or an entire like customer support team or an entire fraud team. So what can we do to get from a smart high schooler level of intelligence to maybe a college graduate level? This is where you will be able to actually take advantage of these models in a reliable way. And this, I'm going to go through like an actual example of how we take models like ChatGPT of the world or like Claude and build a system that is reliable enough that you can actually implement your customer support or like a first line customer support kind of like agents based on this. And this is what is called like an agentic cognitive architecture. And it's pretty simple. So let's go through a use case. Like let's build a customer support chat. A customer, let's look at the components that you need to be able to build this self-service tool. So customer inquiry comes in, that could be phone call, that could be chat, that could be an email. The first thing you need to do is like figure out what is the intent of this conversation, right? Are they asking a question? Are they giving you feedback? Are they complaining? Are they asking to talk to human? So you need to have like a model specialized to do intent detection. And then obviously you need guardrail. You need like an agent that is able to guardrail. And then you need a router to figure out, is the customer is simply asking a question around like, what is my APR? Are they asking to make a payment or like a disputed transaction? And these agents, the operation agent and regulatory agent, they can talk to each other, and the operation agent can escalate conversation to your regulatory agent to figure out, is there a UDAP violation? Is there a Reg EVZ violation? Is there a fair lending violation? And this architecture, if you look at each of these nodes and square, you can think of those as one of those preschooler language models that went to college. And by that, I mean, you basically are able to train them, like fine tune them. You can give them, augment them with extra knowledge to be able to have their intelligence kind of like elevated to a point that are reliable. So you can have like one agent that is really good at flagging UDAP allegation. You have one agent that is really good to know if the customer is asking to make a payment or update their address on their account. So this is pretty much how every AI system today is built for customer support, for fraud, for complaint management. This is the architecture where you basically put a network of specialized models and agents, and these agents or nodes are pretty specialized. They're basically smart to do a couple tasks really well. All right, and one last topic for me before I hand it over to Noan is, this is one of my favorite topics, like financial services, where among the first industries who adopted XGBoost, like machine learning at production and scale. This was back in 2009, 2010, 2011. And fast forward today, we're one of the industries that are falling behind severely. And typically, like you hear like 4 different concerns. There's an accuracy concern, like these models are not accurate enough. There are solutions for that. You can do model specialization, and there are like techniques that I have posted there, like prompt tuning, things of that sort. There is a reliability concern that like, hey, these models might be accurate, but once in a while they hallucinate. They're not able to check their own like output. And there are ways to go around this by a network of specialized agents. There are like ways to control for the hallucination. There is an explainability concern where these models are not explainable because these are like hundreds of billion, if not trillions of parameters. How are you going to explain those? There are actually ways to explain these models. How did they got to a conclusion about a specific topic? And then there's data security concern, which is actually there are like ways to securely deploy your models and do data loss prevention techniques. So all of these concerns, there are like ways to go around it. They're been done today, and there are a lot of use cases as of like today, which these models are deployed in production. I'm gonna hand it over to Noan, who will take you guys through some of these actual real use cases.
Awesome. Thanks, Prem. Cool. So just to quickly introduce myself, right? I'm Noan Bandar. I work for AWS. I think probably all of you, most of you have worked with AWS at some point in your time. My team leads solutions architecture for financial services. So some of the things that Payman talked about, my team is working on implementing them in production, in real world. And some of the stories that I'm going to talk about really quickly today are those solutions that we deployed in production and things that we are seeing the return on investment. Before I go into the use cases, I like to highlight this particular survey that McKinsey did. It came out early this year. Is that a lot of the banks are investing in this particular space, and the biggest ROI folks seeing right now is in customer service. And there's a reason for that, because with conversational AI, with the data that you have in the financial institutions, there's very easily you can do correlation and causation, and then you can provide better and improved customer service for the end customers. Then you can see 81% of the banks are planning to adopt AI/ML to improve customer service, 56% in risk management, 49% in back office, and then it goes down into much more regulated areas in the financial services. There's about $200 to $300 billion of revenue that can be captured by 2026 in these spaces as a cost optimization or net new customer acquisition. So for the purpose of this conversation, I like to kind of categorize our conversation into these 5 key areas. These areas, if you look at, there's a certain amount of overlap as well. So you can see user experience overlaps with personalization as well. When you are trying to provide improved user experience, you need to personalize. You need to personalize the messaging that you are going to provide to your customers. So that's where the overlap is. The other 3 areas in the middle, like middle office operations, risk, credit risk analysis, and fraud, financial crime, those implementations come in a form of productivity improvements. So when I talk to the AWS customers, I kind of broadly categorize into 2. End customer improvement, end customer experience that you provide, and all the productivity improvements that you try to gain into human in the middle kind of operations, right? How can you make your agents more intelligent? How can you make your risk analysts more productive? Within AWS and Amazon, we have this term called undifferentiated heavy lifting. So if you look at if you take a knowledge worker today, they do a lot of undifferentiated heavy lifting in terms of looking at certain data parts, try to make correlations before they are making decisions, before they are making, they're trying to make sense out of that data. So what we are seeing is with AI and generative AI, all that undifferentiated heavy lifting can be automated and provide as insight to that decision maker or the agent or the risk analyst so they can do their job better. So that's where we see the productivity gains. All right, so I'll talk about the customer experience and I'll skip a couple of these slides due to time. One of the customers that my team worked very closely is Black Knight. Black Knight is probably all of you have heard about. It's a company who have created to have technology platforms for the mortgage industry. So in a traditional sense, Black Knight was using AI/ML for the longest time, and they have improved their customer support center or customer support software package using generative AI by implementing intent analysis. So what this means is when somebody calls the call center, before even goes to an agent, the generative AI conversational tool will talk with the particular customer, try to understand why this customer is calling, analyze all the historical information of this particular customer, whether this customer has called last couple of weeks, for which kind of complaints, and provide a summary to the agent before the call is handed over to the agent, provide a summary to the agent saying, okay, this is why this person is calling. This is the best possible solution that you can provide to this particular customer. So Black Knight has improved their call resolution time by 80%. Usually, their call resolution was like 15 minutes to 20 minutes call resolution for complex complaints. This time was reduced by 80% by implementing generative AI. So, and customer experience is the most growing area of disruption right now with generative AI, because you can use data very easily. You can do more correlation and predictive analysis and provide the agents smarter. All right. Then I'll go to middle office operation and touch a little bit about back office operation as well. So this is also not a really new or disrupting space, because financial institutions has been using middle office operations tools for a long time. You probably have heard something called OCR, optical character recognition, right? When somebody gives a document or submits a document to an FTP, there are tools that can scan the document and extract the information from the document, do a rule-based analysis, and tell you like how complete is this document, right? So with generative AI, this has taken into another level. What happens now is when you submit these documents, and PennyMac for a good example, is one of the largest mortgage providers in America, is getting about 180 million documents per year. So what happens is when the documents come to PennyMac's workflow, it not only extracts information, it looks at customers' information, it tries to provide a holistic view to the credit analyst or underwriter to provide, okay, these are the missing pieces. It even goes to a length where it will talk to the customer and say, okay, in order to give you in order to assess your credit worthiness, we need this kind of information, these kind of documents, without involving an agent. So this significantly cut down agents' involvement. And then what happens is once the loan document is complete, it will go to the agent and the agent can do their job much more efficiently. All right. It seems I don't have a lot of time. I'll quickly go to this one last example. And of course, I'm here throughout the day. I'm happy to talk about risk, financial crime with Santander. And this one other customer, NatWest, it's a UK-based, one of the largest banks in US with 20 million customers. I'll quickly wrap up with a story. So when NatWest used their data to segment their customers, what they saw is there are a certain amount of customers who are paying a crazy amount of money for ATM fees. And when they look at those customers are in poor neighborhoods. What they did was ultra personalization and hyper personalization. They sent messages to these customers saying, hey, by the way, last 4 weeks, you paid about £40 on ATM fees. there is an ATM 3 blocks down the road, which is free. Through that hyper-personalized messaging, they managed to save about 20 million pounds per year for that particular cohort of users, right? So that's where the generative AI, you see the power of generative AI, because AI can see the correlations that humans cannot comprehend in large data sets, right? So it will provide this insight to the agents, and agents can action it. I'll stop here for any of the questions. There are so much nuances on how to implement generative AI, and it all starts with data. Why I say that is a lot of work that my team is doing, payments team is doing from Spring Labs point of view, is looking at the data and preparing that data so that generative AI can use that data, right? So if I'm going to leave with one message, invest in summarizing that data, investing in cleaning that data and cataloging that data in the form of source data, right? Don't spend too much time in normalizing and all that. That work can be done by generative AI agents. Thank you. We can take some questions.